Happy day everyone. Welcome to this video lecture series Electronic Circuits and Analysis. Till now in this video lecture series we have derived FET field effect transistor hybrid model and analyzed common source amplifier. In this video we are going to analyze common drain amplifier and we are going to find input impedance, output impedance and voltage gain. Okay, common drain amplifier. What is common drain amplifier? Actually, we know the FET symbol. This is the symbol of FET, gate terminal, source terminal, drain terminal. In the common drain amplifier, we are giving the input in gate terminal and getting the output from the source terminal. This drain terminal will act as a common terminal between input and output. That's why we are calling this particular configuration as common drain amplifier. Now we are going to draw the basic diagram of common drain amplifier. This is the basic circuit diagram of common drain amplifier. In this amplifier, input is given into the gate terminal and output is taken from the source terminal. This drain terminal will act as a common terminal between input and output. Here there are two capacitors, C1 and C2 capacitor. The role of this capacitor is it just isolate the DC component as well as AC component. Input we are giving as a AC signal and output also we are getting the boosted amplified AC signal. But the transistor needs an active voltage, DC voltage. We are giving plus VDD DC voltage. This capacitor will isolate DC component and AC components. That's why we are calling this C1 and C2 capacitor as coupling capacitor. For analyzing this common drain amplifier, first we need to draw an AC equivalent circuit. For drawing AC equivalent circuit, we should consider two things. We have to ground the DC component, DC voltage VDD, and we have to eliminate the coupling capacitor C1 and C2. By considering these two, we can draw an AC equivalent circuit. From the AC equivalent circuit, we can analyze the circuit. Okay. This is an AC equivalent circuit of this common drain amplifier. We have drawn this AC equivalent circuit using FET hybrid model. We know the FET hybrid model. This is the FET hybrid model. This is gate terminal, this is drain terminal, this is source terminal. Actually, in the circuit, source terminal was grounded through RS resistance. That's why we are putting here the source terminal was grounded through RS resistance. And the drain terminal was grounded. Drain terminal was grounded since we have to eliminate the DC voltage plus VDD by grounding. That's why we are putting ground here. And the input side we are having RG resistance and VA input VA voltage is there. This is the AC equivalent circuit. See, in this AC equivalent circuit there are two grounds. This is ground number 1 and this is ground number 2. We need to simplify this AC equivalent circuit to analyze the circuit, because by using two ground it is very complicated to analyze the circuit. That's why we are going to draw a simplified equivalent circuit by merging these two ground, by just folding this circuit. Now we have drawn the simplified equivalent circuit. This current source, this part is folded and we are merging this first and second ground as a single ground. See, this GMVGS is flowing towards downward direction. After folding, we will be getting like this. GMVGS will flow through upward direction. This RD is connected between, one end is connected between ground and another end is the positive terminal of the current source. Same, the one end is connected with the positive terminal, another end is grounded. In this part, the one end is connected with the GMVGS as well as another end is connected with the ground. The same circuit was simplified and redrawn like this. Input side, there is no change. Now, by using the simplified AC equivalent circuit, we are going to analyze and we are going to find input impedance, output impedance and voltage gain. First, we are going to find the input impedance of the circuit. Input impedance is denoted as Zi. Input impedance is nothing but the total opposing factor, the total resistance present in the input loop. Here up to this is input loop, and this is the output part. The total resistance present in the input side is called input impedance. By seeing the circuit itself, we can write Zi is equal to Rg. The only one resistance is there, so directly we can write from the circuit. This is equation number 1, input impedance of the circuit. Now next we are going to find the output impedance. It is denoted as Z0. To find output impedance, we should consider Vi is equal to 0. By considering Vi equal to 0, we are going to redraw the output side circuit to analyze the output impedance. This is the output side circuit. We are having current source, 2 resistance small rd and capital Rs. The current flowing through the small rd is represented as I small rd, and the current flowing through the capital Rs is represented as I capital Rs. First of all, apply KCL in the output node. This is the node A. KCL means sum of incoming current is equal to sum of outgoing current. Here see, the incoming current is I0 and GMVGS. So we can write I0 plus GM VGS is equal to, the outgoing currents are IRD and IRS. IRD plus IRS. This is the KCL equation of output loop. Next, we can write this equation as I0 plus GM VGS. Now we can replace IRD using Ohm's law. Voltage divided by resistance. Voltage here is V0. RD is V0 divided by the resistance is small rd plus V0 again V0 divided by the resistance Rs. We know that from the circuit we can say V0 is equal to minus VGS. How minus VGS means? The current is flowing upwards. In the FET hybrid model, GM VGS will be flowing downwards and the VGS will be parallel to that VGS. But in this configuration, the current is flowing upwards, that is opposite to the input voltage. That's why we are putting minus VGS. So from this circuit we can write V0 is equal to minus VGS, which means VGS is equal to minus V0. Now we can apply this in the above equation. So I0 plus GM minus V0 equal to V0 divided by RD plus V0 divided by Rs. From this equation we can simplify I0 is equal to V0 divided by RD plus V0 divided by Rs. This minus GM V0 will come as like this, GM V0. Now we can take V0 as common, V0 into 1 by RD plus 1 by Rs plus GM. Now the ultimate aim is to find Z0. What is Z0? Z0 is equal to V0 divided by I0, that is equal to 1 divided by 1 by R0 plus 1 by Rs plus GM. We can write this equation as Z0 is equal to RD parallel Rs parallel 1 by GM. This is the output impedance of this common drain amplifier. Next we are going to find the voltage gain. Voltage gain is represented by AV. AV is given as AV is equal to V0 divided by VA, that is output voltage divided by input voltage. Consider this as equation number 1. What is V0? By using Ohm's law we can write V0 is equal to output current I0 into the resistance present in the output loop, RD parallel capital Rs. These are the resistance present in the output loop. We know that output current is equal to I0 is equal to GM VGS. So we can substitute V0 is equal to GM VGS into RD parallel RS. Consider this as equation number 2. Okay, now to find VA, we should apply Kirchhoff voltage law in the output loop. Applying Kirchhoff voltage law in output loop, we will be getting, in the output loop there are 3 components, VA, VGS and V0. So we can write VI is equal to VGS plus V0. We know that V0 is equal to VI is equal to VGS plus V0. We can substitute GM VGS into small rd parallel capital RS. From this equation we can take VGS out, VGS into 1 plus GM RD parallel capital RS. Now the voltage gain AV becomes, AV is equal to V0 divided by VI. V0 we can substitute this equation, GM VGS into RD parallel capital RS. VI we can substitute this equation, VGS into 1 plus GM into RD parallel capital RS. In this equation we can cancel VGS and VGS. Now the AV becomes, voltage gain becomes GM into RD parallel RS divided by 1 plus GM RD parallel RS. This is the voltage gain of current drain amplifier. Okay, thank you for watching. In this video we have analyzed common drain amplifier. In the upcoming videos we will be analyzing field effect transistor in the common gate configuration. Thank you once again.
Achariya, world-class education.